Third normal form. In normalization, third normal form plays an important role while reducing the redundancy in the relations. So here, any relation to be in third normal form, it must follow the two rules. The first rule is the table should be in second normal form. That means whatever the relation given, that must be in second normal form. And second one, the table must not have any transitive dependency. That means if the table is having any transitive dependency, we have to avoid transitive dependency. So this process is known as conversion from second normal form table into third normal form table. Okay. So here conversion is nothing but to remove the transitive dependencies from the table. So these two are important properties for third normal form. Okay, students. So we have to remember the main 2 points. So initially you have to check the given table is in second normal form or not. The relation must not have any transitive dependency. If there is any transitive dependency, you have to avoid and you have to remove that transitive dependency. So then we can say that relation is in third normal form. So what are the uses of this third normal form? So here it is used to reduce the data duplication and it is also used to achieve the data integrity. Okay. So here this transitive dependency, there is no transitive dependency for non-prime attributes. So this very important point, all of you remember, if there is no transitive dependency for non-prime attributes, so then the relation must be in normal form. So now we will discuss what is a transitive dependency. So before going to conversion from one table into third normal form, so we must know the transitive dependency. So it is a transitive dependency is type of functional dependency which happens when it is indirectly formed by two functional dependencies. Example, if I am going to take the relation R A B C. Okay, so we have the relation like this. So there is a functional dependency between A and B, and there is a functional dependency between B and C. Okay, if it allows the functional dependency from A to B and B to C, so then there is a chance for transitive dependency, that is A to C from these two. So there is a chance for transitive dependency A to C. Okay, this is called transitive dependency. Consider the table given here, company. So CEO, age are three attributes for the table. So here company is the super key. Okay, so this company used to uniquely identify all the rows of data. So here we are going to, if we know the company, so you know the CEO. So definitely we are going to determine the CEO from the company. Okay. So here same, if you know the CEO, so this is called functional dependency 1. Okay. So here we find functional dependency 1. Okay. If I know the CEO, so I know the person age, that means CEO's age. So definitely I can determine age from CEO. So this is functional dependency 2. So from this example, so you observe if there is a functional dependency between A to B and B to C, then there is a chance for transitive dependency A to C. Similarly here, age is dependent on company. So this is called transitive dependency. So try to understand. So there is a functional dependency between company and CEO, and again CEO and age. So we have a two functional dependencies. From these two functional dependencies, so we can determine. So it allows you transitive dependency, that is we can determine age through attribute company. Okay, this is called transitive dependency. If you find this type of transitive dependency, so then you can avoid. Then we can say that relation is in third normal form. So here I give an explanation. You see, so company to CEO. If you know the company, so we know the CEO's name. Okay, so CEO to age. This is functional dependency one. So here we are defining the functional dependency. So like A to B. Similarly, company to CEO, and again CEO to age. This is another functional dependency. Okay. So if we know the CEO, so we know his age also. Okay, or his or her age. Okay. Now, therefore, according to the rule of transitive dependency, so it makes a sense. So the age is dependent on company. So this relation is known as transitive dependency. So here that is. So finally, this is the transitive dependency from the existing table. Okay. So it makes a sense because we know, if we know the company name and we know his age. Okay. So that is transitive dependency. So I hope you understand clearly about transitive dependency, and you have to remember there is a one rule. If there is a transitive dependency, or if you are going to convert into second normal form into third normal form, that means the table must have at least two or three attributes. Okay, two or three, sorry, three or more attributes. Okay, three or more attributes. So this is very important point, all of you remember. Okay, so now here we will see an example how to avoid the transitive dependencies. So here you can see the employee detail table here. Okay, so observe the columns: employee ID, employee name, employee zip, employee state, and employee city. So just I want to find the functional dependencies. So if you understand the attributes and you have to find the closest relationship between attributes, then you can determine the functional dependency between attributes. Okay, so here you can see this employee state and employee city is dependent on employee zip. So now this is a functional dependency one. Okay, so this employee zip is dependent on employee ID. So this is a functional dependency too. So now there is the dependency between employee zip and employee state and employee city and employee zip and employee ID. Now there is a chance for transitive dependency between employee ID and employee state and city. So now, so this table is not in third normal form. So we find transitive dependency. Now we want to avoid this transitive dependency. So then we can say the given relation is in third normal form. So what is the procedure? Just you can see, if we have a transitive dependency A to B, okay, and B to C, so it allows transitive dependency A to C. Okay, see here, if there is a functional dependency A to B and functional dependence B to C, then it allows the transitive dependence A to C. Okay, this for your understanding. For your understanding, I given this picture. Okay, A to B is a functional dependency and B to is a functional dependency. These two dependencies allows the transitive dependency A to C. Okay, how to avoid this transitive dependency are rule to resolve the transitive dependence. Okay, so here the table is in second normal form and we have to convert into third normal form. So here we find two functional dependencies, A to B and B to C. So now the procedure is we have to this table we have to break into smaller tables, or we are going to decompose these tables into smaller tables. So that is how we are going to divide. Okay, so the functional depending upon the functional dependencies. So here this is the total functional dependencies, and we have a transitive dependency here from A to C. Now we want to resolve this transitive dependence. So how? So here you can see we are going to create two relations from these two functional dependencies. So there is a functional dependency between A to B that I created as a relation 1. So I'm going to create, there is a relation 1 only with functional dependency A to B, and relation 2 only the functional dependency between B to C I am going to create with relation 2. Okay, now we separated the relation R A B C to we divided this relation into, so that means there is a transitive dependency. Now to avoid this transitive dependency I am dividing this relation into two relations, R1 with attributes A comma B. This is one functional dependency. Okay, so B and C are not independent, B and C are dependent to each other. Okay, so now this is relation 2. Okay, so here B C. Now we can say R1 R2 is in third normal form. Okay, so try to understand. So if there is a transitive dependency, how we are going to resolve, decompose it into two relations, that is R1 and R2. Okay, and now so same example here we divide into two tables. One table is named as employee table. Okay, and another table I am taking as employee zip table. So here you can see we divided with columns, and I am taking as a common column. That means I am going to relate these two tables together. So that is no problem. You can take extra column also. So that is not the rule. Only you can take A comma B, and you can include C, and this C is, and but while taking and while inserting and while you are preferring to add another column, so be sure that don't allow transitive dependency. Okay, if there is a transitive dependency, so then okay, again we have to convert into third normal form. Okay, so but here okay we divide the first functional dependency as a one table format and second table. Okay, now these two tables are completely in third normal form. Okay, see here employee zip is the candidate key or super key, so uniquely identify the each and row of data. Okay, similarly here employee id is the candidate key, it can uniquely identify each and every row of data. Okay, so here we can define the dependency between employee id and employee name, and we can define the dependency between employee state and employee city. Okay, so now this is the process for converting a second normal form table into third normal form. So initially the table must be in second normal form, and then you have to find if there is any transitive dependency. So you have to remove that transitive dependency. That means you have to convert into third normal form. Okay, so this process is called conversion of a given relation into third normal form relation. Okay, so this is a one example, and we will see if we have a relation student system. Okay, so don't expect all time they are giving the entire table with the domains. Okay, so here sometimes they can ask the relation, so relation schema. So then you have to define whether the table that relation schema is in third normal form or second normal form. Now I am asking to convert this relation schema to third normal form. Okay, see students, here try to understand the attributes and their close relationship. So here we have a roll number. So this table name is called as a relation name is called as system, student system charge, roll number, name of the student. So particularly student using the system, and he has to pay the money according to hourly basis. So that is called hourly rate. Okay, now try to find out, is there any functional dependency between these attributes. Okay, first you will find what is the prime attribute here or candidate key here. So here you can see the relation student system charge. Okay, so find which one is the suitable for to uniqueness of data to retrieve all the rows of data. Okay, so in this case non-prime attribute hourly rate is transitively dependent on primary key roll number. Okay, through the functional dependency. So here you can see, so directly he written functional dependency, transitive dependency. Okay, so here you can see, so there is a functional dependency between roll number and system use. Okay, because we are assigning each and every system to particular student with their roll numbers. Okay, after some time he is using system for 3 hours or 5 hours, and we are going to calculate his amount. Okay, that is hourly rate. So this is another dependency. So we have two functional dependencies. So from these two it allows the transitive dependency. Okay, it allows the transitively dependence. Okay, transitively dependent. Hourly rate is transitively dependent on a roll number. Okay, so this we have to avoid in this relation schema. So that how we are going to avoid? We are going to avoid by dividing this relation schema into two relations. So one relation is student system with the name student system. So we are including the attributes roll number, name, system used. Okay, and again charges, system used, hourly rate. Okay, these two relations, now it is in third normal form because there is no transitive dependency between attributes. Okay, so this is an example when they given relational schema how to convert into third normal form. Okay, so for that example I given the values and I divided into two tables for converting into third normal form, that is a student system and charges. Okay, now Boyce code normal form, it is called an extension or advanced version of third normal form. Okay, so here why it is named as Boyce code normal form. So there are two persons, okay, invented this. So Edgar F. Ford and Raymond Boyce, these two invented this normal form, and here it is more stronger than third normal form. So, and it is a better version compared to the third normal form. Okay, so this is Boyce called normal form. Okay, now we can see. So what is a Boyce called normal form? Again, here it is also referred as 3.5 normal form, that is better version of 3NF. Okay, so it is a stricter than third normal form, that is, or you can write stronger than third normal form. Okay, why it is a stronger? So we can remember here, if you want to convert a table into third normal form, a table into Boyce called normal form. Okay, So you have to remember 2 points. Okay, one, the table must be in third normal form. After that, if there is a functional dependency, in that functional dependency, so here you can see x to y, x should be the super key of the table. Okay, x should be the super key of the table. Okay, so these 2 points, if it satisfies, then that table is in Boyce normal form. So students, just consider, okay, this example: employee ID, employee nationality, employee department, department type, and number of employees in department. So here this table contains two relations: information, department, and employee details. Okay. So here you can see number of employees are working in an organization and different nationalities, and they are working in different departments. Okay, not in same department. They are working in different departments. Okay, this point you have to remember. That means there are multiple candidate keys. That means it allowing multiple candidate keys. Okay, so determinant may be, composite key, or okay, we are using combination of 2 3 attributes. Okay, so just from this example you can see there is a company where employees work in more than one department. They store the data like this. Okay, so initially the functional dependency from this table, so employee id. Okay, here, so employee id is the unique ID for each and every employee. So uniquely identify each row of the data. Okay. So that employee ID. And what is the other one? Employee department. So department is also unique to each and every person. And using this ID, we can retrieve the department type and number of employees in each and every department. And we are using here two candidate keys, employee ID and employee department. So in this table we have two candidate keys. Okay, so from these two candidate keys you can retrieve, okay, all the information, that is employee ID, so and employee name and department number and department type. Okay, that is the number of employees in department, whatever the information available in the table. But here it, the determinant must be a super key. Okay, so only one key. Okay, so only one super key or one candidate key. Okay, so here this value must be one key. So now we have a set of super keys or set of candidate keys. Now this table is not in the form of Bcnf. Now we want to convert this table in Bcnf. That is, again we are going to decompose this table into two or three relations, small relations. Okay, so see how we are going to divide this table. Okay, now here you can see I am going to divide the table as with one relation, that is employee national table R1, okay, and employee department table R2. That includes all the attributes in the previous table, but these two we are dividing. Why we are going to dividing? There is a more than one key in determinant, super key, but we have to prove that if it is in BCNF, there is a functional dependency, that must be a only one key. Okay, only one key. Then we can say that relation is in Boyce normal form. So here you can see R1. So here only one candidate key, employee ID. So here remember the definition. Candidate key is a super key with no repeated attributes. Okay. So we will not going to define any attribute together with another attribute. Only here only one key. So employee nationality you can access only based on, and the employee ID is dependent. It's dependent on employee ID. Okay. So here also employee department. Okay. this candidate key, this department type is dependent on employee department, number of employees in department is dependent on employee department, only one key. Okay, so now we can say these two relations are in Boyce called normal form. So this is mapping table. So to avoid the data redundancy, so we will use this mapping table. So whenever you want, you can map based on the employee ID with the first relation and employee department with the second relation. Okay, so that we know the constraint is used to link one or two tables using foreign key constraint. Okay, see the same here I given here. So functional dependencies in relation 1, functional dependencies in relation 2. So we have a first table, we have only one key, and second table we have only one key. Okay, so third table, so that is a mapping table. So we are using employee ID to mapping to first relation, and employee department is used to mapping for second relation. Okay, now this is in Boyce called normal form. So another example. So here I given more examples to understand. So actually these examples I got from various websites, Java T Point, Jigs per Jigs, beginnersbook.com, study29.com, so many websites. Nowadays we have a lot of material, okay, and I am also using that websites as a reference. Okay, now here you can see 1001 employee numbers, 1001, 1002, 1007, 1007. So many employees are working here, and employees are working in different departments, and same department having multiple department heads. Initially you can observe the attributes. Okay, so here we have same department, so we find two different department heads. Okay, two different department heads. Okay, so similarly 1001 is working in a New York City, but departments are two different. Okay, he is working in two departments. Okay, so try to understand and try to find out how many candidate keys are there. Okay, so here we find two candidate keys. Okay, so employee number is one candidate key and department name is another candidate key. So to retrieve the unique to uniquely identification of each and every row of data, we are using two candidate keys. So department name and employee number, okay, are super keys. So department name is a prime attribute here, and so based on these two columns, we can identify each and every row of data so uniquely. So now, so this department name depends on department head, which implies that department head is non-prime attribute. Okay, so we have to show that department head is prime attribute, then that relation is in Boyce called normal form. This criteria disqualifies the table for being part of a Boyce called normal form. Okay, now so we are resolving this issue by breaking the table into three different tables or two different tables. Okay, so you can use three small tables or two small tables, so that is not a problem. So here I am going to define this into two tables. Sorry, here it is a, or you can see, yeah, here it is a two different tables. Okay, not three. So employee table and department table. Okay, so I am relating these two tables by using the department number. So here it is the employee number is the candidate key, and here department name is the candidate key, or you can take department head. Okay, is the candidate key, so we can access the department name is depending upon department head, so department number is depending on department head. So here all these are depending on employee number. So now, so here x to y Okay. So X is a super key. So similarly here X is X to Y, that is X is a super key. Now we shown that the given two tables are in Boyce normal form. And another important is, so what is the difference between third normal form and Boyce normal form? So here, so first you can define what is the third normal form. If third normal form means there should be no transitive dependency, then we can say that the relation is in third normal form. In Boyce normal form, in functional dependency A to B, A should be a super key of a relation. Then we can say that that relation is in Boyce normal form. And which is the stronger one here? Comparatively third normal form. Comparatively third normal form. Boyce normal form is strongest than third normal form, but it is compared to Bcnf, it is a less stronger. Okay, so here in third normal form, only the functional dependency is already in first normal form and second normal form. Here, the functional dependencies in Bcnf already in first normal form, second normal form, and third normal form. And here, little bit redundancy is high in third normal form. So the redundancy is comparatively low compared to third normal form in Bcnf. Okay, these are the main differences. So then preservation of dependencies, there is a preservation of all functional dependencies in non-normal form. Bcnf may or may not be preservation of all functional dependencies, and it is comparatively easier to achieve non-normal form because just simply you can avoid the transitive dependence. You can achieve easily, but here we have to find set of candidate keys, okay, and that determinant is only one super key you have to prove. So then it is somewhat compared to third normal form, it is difficult to achieve. Okay, so lossless decomposition can be achieved by third normal form. So lossless decomposition is hard to achieve in Boyce normal form. Okay, these are the major differences between third normal form and Boyce normal form. Thank you.